We're going to bring Andrew Jones up to be our first startup presentation for the morning. We have 3 in this lineup before lunch. Just a reminder about how this program works. We're one of the only programs in the country that actually provides pilot opportunities to startups. We are here to help with the commercialization valley of death. And so to be able to help startups during that difficult time and make that happen in Minnesota, Andrew's just such an incredibly brilliant person, and I'm excited for you to hear about it. These are the folks in our 2024 program. And you will have again, reminder to look for the green lanyards as you're moving through the day today. But with that, I'm going to hand it over to Andrew.
Awesome. Thank you, Nina. I think we all need to give a round of applause to Nina, who is a rock star, for putting on this event and getting all the right people in a room together. That's a pretty incredible feat. So kudos. And to Lily for helping put on this event. Representative Kraft said that efficiency is sexy, and I wholeheartedly agree. I started an efficiency club at the U of M. My goal today is to convince you that waste is sexy and that carbon removal is also sexy. So I'm going to dive right into this. I'm going to talk to you about how we're converting our waste, specifically biomass waste. Does anyone know what biomass is? It's just everything that grows, right? Trees, plants, algae, seaweed. How we can convert those waste products, which are waste, into value, specifically into carbon removal, but also products and biochar and materials. Do I have a clicker? Oh, I do. Okay. But first, a little bit about myself and a little bit about the founders of Carba, our company. So Professor Paul Downhauer, I actually met him back in 2005 at the University of Minnesota. And it was back then that we were converting biomass into hydrogen, into aviation fuels, into plastics, into all these sorts of things. And that's what got me really interested in chemical engineering and why I've devoted my life to understanding these problems. Paul has gone on to spin out 5 companies from the University of Minnesota that are converting biomass into things like soaps, plastics, and then 2 companies with me, one with carbon removal and my previous company. We also have Nick Halla, who was on the founding team of Impossible Foods, which produced a lab-grown meat using heme protein, and it's delicious if you haven't tried it. Myself, I'm an entrepreneur. I get incredibly excited about all things energy, all things carbon, and I have been working in this space for the last 20 years, starting at the University of Minnesota. I ended up going to UC Berkeley to do a PhD in chemical engineering focused on heterogeneous catalysis, which is just a fancy way of saying materials that make things happen faster. And that focus was in fuels. I started a company out of school. About 10 years ago, I moved back to Minnesota, started a company with a local businessman, and we made detectors and measurement equipment for greenhouse gas measurement, for fuel measurement, for all sorts of things. We recently sold those products off to Shimatsu Corporation out of Japan. And I started Carba 3 years ago because I saw that the planet was in a dire circumstance. We needed to take action in the next 5 to 10 years, or we are going to be in a whole lot of hurt. So our vision is to remove billions of tons of carbon dioxide from the atmosphere. So with a show of hands, who understands the difference, or that there is a difference between decarbonization and carbon removal? Does anyone understand that? Actually, a lot of you guys are a sophisticated group, but for those of you that don't, decarbonization is switching off of fossil fuels or reducing fossil fuel usage. An example is switching to an electric car from a gas car and using renewable energy to power that car. Carbon removal is actually physically removing legacy or old emissions from the atmosphere and then doing something with them, hopefully hiding them and preventing them from emitting forever. The reality is, to solve the climate crisis we're in, we have to do both. There's no scenario where we can't do both. We have to switch out of fossil fuels as quickly as possible, but we also need to suck out and remove as much carbon dioxide from the atmosphere as we can. About 10 billion tons per year by 2050 is what the National Academies of Sciences have said, and that's a pretty big feat. We know how to decarbonize. We have good solar technology. It's incredibly cheap. It's 10 cents a watt now for panels. Wind is cheap. We have battery technology. We don't have a lot of good technologies to remove carbon dioxide, and they're currently very, very expensive. So that's what I've focused my time on the last 3 years, is how to solve that. And the good news, I want to say, is we have a solution that is very affordable, and it's ready today, and we're deploying it here in Minnesota to start. The solution involves biomass waste, so things that grow. And there's about 40 billion tons of biomass waste around the world. That's more than enough to solve the climate problem on a carbon removal front. 40 billion tons. Now, what happens to that today? Well, in a lot of places, it's piled up and burned. So you go to rural Minnesota, you go to Asia, you go to even Europe, they pile it up and burn it, if it's agricultural waste or wood waste. The other solution is compost. They put it in these compost fields. That's what we do here in the municipal area. There's a bunch of compost facilities. We pile up the waste, we try to aerate it, and try to break it down fast. That breakdown is degradation, and that releases all the carbon back into the atmosphere. So it's also not great. That releases CO2, and about 2% of that carbon goes out as methane in those compost piles, depending on how well you aerate. So this solution exists, and people are actually paying to get rid of this waste in certain places. So what do you do with this waste? Well, again, my background was in catalytic pyrolysis back at the University of Minnesota 20 years ago. One solution to this is to take that waste material, which is a food source. It will biodegrade whether it's underground or above ground because it's food. We can do a heating of that material called pyrolysis, and it breaks the bonds. It removes the food value of the wood, and it makes something you're all familiar with, which is charcoal or biochar. It's a black material that's left over after a fire. Well, if we control the heat and the oxygen in that reaction, we can make a lot of that biochar, and that will lock up the carbon in those molecules that used to be CO2 in the atmosphere. And then we can take that carbon and we can use it in different ways. One way is to actually bury it underground where there's co-benefits, environmental co-benefits that I'll get into. And it locks up the carbon, prevents any decomposition above ground, such as oxidation or free radical mechanisms that might remove carbon. We can also put it into materials like tires, asphalt, concrete. And we can also use it as a coal replacement, although that's probably, from an environmental standpoint, let's not burn carbon if we don't have to. But in things like steel production, there's still a need for coal, even in electric arc furnaces. So we can do this, and we can do it at scale, and we can do it for very low cost. And the key technology drivers for this that we've developed, and the reason we're in this Grid Catalyst program, thank you, Nina, is because we've developed a technology, a reactor technology that can give the highest yields. So we can double the amount of biochar you produce for every ton of biomass. And we can do that in a scale and at a cost that's attractive. The second thing is this burial technology. How do you bury this to lock up the carbon, but also have environmental co-benefits? Because we don't want to just go around burying wood waste or burying biomass underground or injecting it underground with no co-benefits if we don't have to. And the reality is we can do this in a way that removes PFAS from landfills, that removes fugitive methane emissions from landfills, and it remediates mines. And when you look at the economics, we are a factor of 10 times cheaper than direct air capture. This is open market pricing. We are also a factor of about 10 times lower in energy use. Again, CO2 is an energy problem. We get CO2 because we burn fuels for energy. We want to use low energy to put it back underground where it came from. So when you compare energy and price, we are the leader in the permanent removal space. And that's what makes me so excited about this technology. The carbon removal marketplace is part of the problem. So we were talking about with Representative Kraft, how do you define the problem? Well, part of the problem is that we have a voluntary marketplace for carbon. We don't have a true price for carbon in this country. There is one in Europe, and it's about $80 a ton, and we can be profitable doing that, which is great. But in this country, for a number of reasons, it's a voluntary carbon market. So you have big companies like Microsoft and Google and Amazon leading the way and buying credits and creating this voluntary carbon marketplace. But we really need regulation to regulate what is a true waste product. Today, we pay to get rid of our garbage to landfills. We don't pay for the CO2 that we emit into the atmosphere because we can't see it. I hope that changes, but it probably won't. Nonetheless, there is a voluntary market, And that is driven by companies that have made net zero pledges. And they can't get to net zero on their own. They can electrify as much as they want, but there's always some emissions that they need to purchase to get to net zero. And that's what's driving Microsoft to spend hundreds of millions of dollars on carbon removal credits across all sorts of types. The CDR market is $2.7 billion today. It's predicted to be $100 billion by 2030, predicted to be $1 trillion by 2050. So it could be one of the fastest growing markets, aside from AI that we've seen. There's an issue though. Only 3% of the purchases have been delivered, and 94% of the purchases are biochar, which is doing what we're doing, but applying it to lands, agricultural lands where there's agricultural benefits. The market is looking for something that's more permanent, like direct air capture, where you're pumping underground, but at the price point of biochar. And that's exactly what we're offering. We're offering the low risk of underground storage at a price point of biochar, which is attractive to buyers. And so we're filling that gap with what we call permanent biochar burial. We have an active pilot down in Burnsville, Minnesota on the waste management landfill. And the beauty of that site is we can take the compost that gets dropped off there. There's 30 to 50,000 tons there. There's about 1 million tons of biomass in the Twin Cities alone. That's 1 million tons of potential carbon removal that we can do just in the Twin Cities. We are affiliated with Isometric, which is a leader in the space of being a third-party registry. And so they're certifying that what we're doing is permanent, that we're doing it correctly, we're not a bad actor, which is super essential because in the early days of the carbon markets, there were a lot of afforestation, reforestation plays. 94% of them were BS. And even though they were third-party registered, and there's a lot of articles about that, it's really unfortunate, and we need third-party registration, and we need permanent removal. So we see the market shifting to these more permanent, measurable removals. Now, what I really love about our technology is that we're not just removing carbon from the atmosphere and storing it somewhere. We're also utilizing the material that we make, this biochar, to do something good for the planet. And in this case, in landfills, we have a PFAS problem. And Minnesota is ground zero for PFAS, tomato. PFAS, if you're not familiar, they're these perfluoroalkyl species, basically these long carbon chains with a bunch of fluorine on them. And they're really great for non-stick. And they're in a lot of our carpets, they're in a lot of our clothes for waterproofing, they're in our pans. The problem is, it was a great material. The downside is they last forever, they bioaccumulate, and they cause cancer and kidney function failure and all these other things. And so you cannot find a human cadaver sample that doesn't have PFAS and that doesn't have microplastics in it. It's an issue. They're bioaccumulating. How do we get rid of them? This is one of the only solutions that can do this at scale for a reasonable cost. We can take biochar and put it into landfills as daily cover. So you create this sort of layer cake, waste, soil, and biochar, waste, soil, and biochar, which is already a legal requirement to put soil on top. And it acts like a filter in the landfill. And we can suck out PFAS and other chemicals and toxins and prevent them from going out your leachate into our drinking water. The second thing we can do is reduce and remove methane from landfills and reduce it from compost facilities. So anytime you compost, there's gonna be a non-negligible amount of methane being formed. Methane is about 80 times worse than CO2 on a 10-year time frame and about 30 times worse on a 100-year time frame. We can prevent that material from composting or decomposing. Again, it's a food. It's gonna be eaten by microbes if you don't do something about it. And we can also put it in landfills where it will eat methane that's being produced in a fugitive fashion in the landfills. So we can kill 3 birds with 1 stone: carbon, toxins, and methane. And we can do it at an incredibly low cost that's 10 times lower cost than direct air capture, which is getting all the government funding. So how can you help? I actually have 2 things listed here. I have a third thing as well. First and foremost, you can purchase carbon removal. That marketplace that I talked about, that's $2.7 billion. It's very fragmented. People don't know what to buy. They're buying $800 per ton direct air capture. They're buying $10 per ton nature-based afforestation, reforestation credits, and everything in between. And it's sort of the new days, which is where I love to be. I love being in the fuzzy front end. I'm an entrepreneur, but we need to develop that market, and we need people like you taking action in that. Especially if you're on a corporate sustainability team, this needs to be a part of your strategy. And we've talked to a lot of folks in sustainability teams, and they're across the board. You have Microsoft taking immediate action. They're one of the leaders. You have other folks who it's a part-time job. They're trying to figure out how to make their company net zero by 2030, and they have no idea what to do. And I don't blame them. There's a plethora of information. So we need to solve some of those issues. We're also financing and building out these reactors, and doing that on a voluntary market is difficult. So looking for unique financing opportunities in addition to just equity financing. And the third thing is we're hiring a head of commercial soonish, and so we're raising our seed round, and once we complete that, we will hire a head of commercial. So looking for badass people who like to do business development at the edge of climate and technology, and want to make a difference. So with that, thank you, Lily. With that, I will close, and if there's any questions, would love to take them if I have time. Thank you.
Andrew, great presentation. Rob Davis with MRETS. We're North America's largest clean energy registry. So we're very excited about carbon sequestration and all the jobs they could bring. Do you see an opportunity for the state of Minnesota that's already investing in educating the rest of the world about how great Minnesota is, and they should come and visit here for tourism? Do you see an opportunity for the state of Minnesota to say, actually, we want you to move here? We want all of you people that are passionate about working in climate, working about clean energy, to uproot yourselves from your lives in Oklahoma or Massachusetts or Oregon and come to Minnesota and all work for Andrew. Is that an opportunity you see?
Thank you, Rob. 100%. Yeah, I moved from California to Minnesota, and the Californians were like, what are you doing? Where's Minnesota? Is that Canada? 100%. I love the reports that show that Duluth is like one of the best cities post-climate change. Minnesota's at a unique position, not just from climate, but from all the industry and the cross-section of what we do. And I tell a lot of the VCs out in San Francisco that, you're funding all these coastal companies doing carbon removal work. All that work's gonna happen in the middle of this country. And so I'm excited about Minnesota at being at the forefront of this. And 100% I want them to come visit, see Minnesota, and Minnesota to be a leader in this space, which I know we can be. We have incredibly great talent here from all the companies, from the university. We know how to do things. We know how to get things done, and we're heavy industry. And this is hard tech. This is not moving electrons like software. This is moving physical carbon. And that's going to happen here, not in San Francisco.
Okay, one more.
Andrew, how do we purchase carbon removal well? What specific guidance would you give us to do that?
Yeah, I mean, there are a lot of marketplaces out there. Unfortunately, I can't recommend a single one as sort of the place to go. Right now, the best thing to do is to buy directly from the manufacturer onto the supplier. It's a great question. I think it's a big part of the problem with the industry as a whole. It's just pretty fragmented, and there's a lot of different marketplaces that are trying to figure out what makes sense, what doesn't make sense. I would go isometric that I showed. They're trying to lead the way in sort of transparency and certification of the right kind of projects and products. And so, that's a good one to start with. Puro Earth is a leader in biochar, and they've been leading that from the registry side. So I kind of start with the registries and then figure out where to buy from there. Good question.
Is buying directly from you, is the best way to do that, to email you?
Email me or email sales@carba.com. Yeah. Thank you.
Thank you, Andrew. Always good to start out with a little Gopher Proud. Happy to welcome Spencer Harrison, and if he'll just let me say this really quick. I've actually been working with Spencer for almost 2 years, and today was the first day we got to meet in person. So this is like super awesome. You do these virtual programs, and you want to bring talent to the state. So for me, super exciting day to have Spencer here to talk about Neocharge, all the way from California, but he'll tell you all the good stuff.
Wow, thank you. Well, yeah, I'd like to thank everyone that came here today and all the supporters and Nina and Grid Catalyst for helping make this happen and funding all these beautiful companies. You know, in many cases, you know, there's a chance that many of us may not be here without this sort of funding, and just super grateful for that. So thank you all for having me. So yeah, I'm Spencer. I'm the co-founder and CEO here at Neocharge. And this stat is really a big reason why we're here today. And that's that in the US, in the next 20 years, for us to hit our net zero climate goals, we'll need to replace or install over 1 billion home energy devices in the next 2 decades. This includes things like our vehicles, what we're cooking with, our water heaters, our dryers, our cooling and heating, and even EV chargers and solar. Now, as you think about these devices, what is one thing that all these have in common? Can anyone guess? Yes. So they're all connected to your home electric panel. Now, as you install all these devices, many times it can require a new circuit, and that new circuit can trigger an upgrade in your panel, which can cost thousands of dollars, and that's really the reason why we're here today. And it turns out if you look at these panel upgrades, as we electrify all these homes across the US, it's a $100 billion roadblock to electrification in the US. That's, you know, electric appliances, that's all the devices I was just showing you. And that's really why we started the company Neocharge about 6 years ago. And we started with a product called the Smart Splitter. The Smart Splitter is a 240 volt circuit splitter that allows you to share 240 volt outlets in your home. What's great is you don't need to get an electric panel upgrade because you can share 2 different devices on one existing circuit in your home. Think something like, you know, a dryer and an EV, 2 electric vehicles, or even 2 electric appliances. And like I said, the big benefit is you don't need those panel upgrades because you're using an existing circuit in your home. And it's also a critical solution for home renters who can't always install charging in your home. It's actually how the company started. You know, I had a Nissan Leaf. I couldn't install charging in the home I was renting, and that's where this spawned. On top of all this, as a lot of us know, the EV market is taking off at an exponential pace. Right now, we're just over 4 million EVs in the US, but by just 2030, we're projected to have over 26 million EVs on the road in the US. And we're seeing a similar trajectory here in Minnesota. Right now, we're just over roughly 50,000 EVs, but just by 2030, we're projected to have over 650,000 EVs in Minnesota alone. And now as you think about all these new home energy devices, all these new electric vehicles that are coming onto the grid, when you're using energy can literally make or break the grid. And that's why we created our second product, a software platform called the Neocharge app. And what we're doing is we're really trying to help optimize and track home EV charging and home energy to better support the grid. And here's how it works. First, you can connect your electric vehicles to the platform, connects directly to the vehicle via telematics, so it's all done via the cloud. You don't need additional hardware, connects directly with your car. Second, you can set up smart schedules for different days of the week, ultimately helping you optimize if you have a variable or time of use utility rate. You can charge at times that are cheaper to help you save money. Third, you can control and view all of your EVs and soon other types of home energy devices all in one place. And lastly, you can track all of your home EV charging and home energy sessions and connect up your utility rate to understand exactly how much you're spending. Now, we're currently integrated with over 14 different EV brands in the US, which comes out to roughly 90% of US EV models. And we're working with some of the top utilities, like Nina was saying, I'm from California, so we've worked with a lot of California utilities, and a lot of these programs have been specifically geared towards low-income communities who can't get access to these technologies, whether they're renters, and that's where we've been working with companies like PG&E, where we have a full rebate for our products for low-income communities, and same with SMUD and others up here on the screen. But ultimately, to help enable home electrification, EV charging, making it as easy and accessible and affordable as possible. Now, in terms of what we're finding with the software, and one of the reasons why we're here today is some key benefits we find with our software for EV drivers is one, by matching up when energy is being used versus the marginal emissions that's localized on the grid, we can actually reduce carbon emissions by up to 90% from EV charging just by optimizing the timing of that. Second, we can also reduce utility bills by up to 70% for those that have a variable or time of use rate, just by shifting that to times that is more affordable. And this also supports utilities. Some of the handful of ways we support utilities is one, by managing load on the grid, we can help reduce these dirty and expensive peaker power plants that are needed when a lot of energy is being used at one time. And we also help reduce peak energy load and ultimately grid infrastructure costs, helping utilities save money, but also helping EV drivers save money at the same time. And why we're here today is we'll be working with the University of St. Thomas in their microgrid labs to help really validate our software, some of the new features we're building, and really understanding how this impacts EV drivers and how this impacts the grid and utilities, and really putting numbers to, hey, how big will this be on a larger scale, and what does this really look like in real life? So we're here today because we're all likely helping become a grid catalyst. And we'd love to work with you, whether it's number one, where we're helping optimize home EV charging in the home, whether you're a utility, or the app is also available on the App Store if anyone has an electric vehicle. Second, whether it's helping enable easy and affordable EV charging installation, whether that's for low-income and disadvantaged communities or others. And lastly, we'd also just love help provide rebates, incentives, and education to EV drivers to really help it become a better experience and just make things easier and more affordable. So my info's up here on the screen. Thank you all so much once again for having me, and I'd love to answer some questions.
Spencer, we have probably at least 5 minutes for questions, folks. I immediately started looking for Rob Davis, because he always has a question. One in the back here, yeah.
What problems are you now encountering? Obviously, you've got a go-to-market, but what ecosystem challenges are now next here? Is it, say, a standard? Is there a need for a standard API integration to utilities? What are the ecosystem challenges you're running into right now?
It's a great question.
Could you repeat the question?
Yeah, he was asking what really some of the ecosystem challenges are that we're facing or we're seeing in the space. I would say one is really, how do you integrate in with the grid in the best way possible? You know, each utility, like in California, obviously it's very different. Everything is regulated in kind of a different way, and there's just different ways that you can integrate with the grid, and we have an integration partner there, but in other parts of the country, it's a lot harder just with the way everything's set up. So that's definitely been a challenge. And also just getting the awareness out, you know, that's been something that, I mean, we just launched kind of a few months ago with the software, but that's definitely been a key challenge. There are some certain integration partners that help you integrate with some different devices, which help you optimize those and support the grid. So luckily that is something that's on the market today. Okay, thank you.
So, because your company is based on the number of EVs you have, right? But I think the most significant challenge in the United States is lack of EV infrastructure, especially on highway. Because what I've heard, people driving a gasoline car from here to Chicago, maybe 6 hours, but someone having an EV spends them like 14 hours from here to Chicago. So, any idea about is this type of problem might be a resistance for your company's growth?
Yeah, the way that really I see it and why we started the company in the first place is that we found that there's a stat, 80% of electric vehicle charging happens at home. And it's not like, you know, how often are you going on a long trip? I mean, you know, in certain cases you are, but most of the time you're, you know, gonna be at home, you're charging at home, you just wake up and it's ready to go. I do think DC fast chargers and getting these chargers along these highways, which I believe there's a lot of funding for that, that's going to be critical, especially, when some people think about EVs, that's the first thing they go to, whereas, a lot of the charging is actually happening at home, but that's also going to be critical to have these commercial chargers. So when you are going on, a trip to New York or you're going to California, you have somewhere to charge, and that's going to be critical. So I do see it as something that's critical. I don't necessarily think it's going to make or break our company because we're so focused on the home and where a lot of the charging is happening. But I do think it's critical just for the US in general.
Thank you very much. Because for my personal story, I'm not able to buy an EV because I live in an apartment, and this apartment has no EV charging. So
That's a tough one.
that's why like you need to work closely with politician, legislator, how to encounter this kind of issues, like would help your scaling.
Yeah, and I just briefly say I think that's one of the biggest gaps is in like multi-unit dwellings and apartments where you can't just install charging and you don't have any control over that, and having rebate funds or different things that are incentives to put these EV chargers in multi-unit dwellings and apartments so people like you can get EVs, I think is going to be really, really critical. Even putting these DC fast chargers and home charging aside, that's a critical sector that I think we need to focus on more.
One more question over here.
Yes, Spencer. You kind of touched on the value proposition and the cost-saving aspect of the home side electrical upgrade. Have you done a side-by-side comparison for like two 60 amp circuits versus a single 60 amp circuit in your Hartford?
Definitely. I mean, that was a big reason why we started. And right now our customers save roughly $2,000 on average by avoiding a panel upgrade. So that's really what we found. It's like instead of installing a new circuit and having to upgrade that electric panel, which usually costs, I think the average is $200 to $2,500. With our product, it's $300. You can just plug it in. You can take it with you when you move if you're a renter. And most people save around $2,200 is the average right now between our customers. So yeah. Did that answer your question? Cool.
Okay, that was a short one, so yes, Russ, start.
I feel like the splitter concept is great and maybe works better out west where washer and dryer tend to be in the garage, and here we tend to have them in basements. I'm wondering if you thought about that question and challenge for our,
Yeah, it's not the first time I've gotten that. Yeah, so there's a few different use cases with our product. A key one is with the dryer and EV. Like you said, not a lot of people in Minnesota have dryers in the garage, completely understand. And we actually do have a lot of customers in Minnesota. Another use case is having two electric vehicles on one outlet, so that could already be installed in the garage. Recently, we've won a handful of grants, one from the Department of Energy, one from the California Energy Commission, to build additional products that can support more homes, because obviously not every home is going to have that 240 volt outlet in or near the garage. We understand that, but there's other ways to be smart about how you place appliances in homes. And we've done a lot of work with the National Renewable Energy Lab to show, like, if you do it in these ways, most homes don't need a panel upgrade, but you just need to be smart about it. So we've got funding to build out some new technologies, and got funding from Grid Catalyst to really help us validate some of these things. And yeah, we're definitely thinking about how we can build on and make it so roughly, 80% of homes could use this certain technology to avoid that panel upgrade. But yeah. Thank you, guys.
All right, we're going to bring up our last speaker before lunch. Scanning the room for Sophia, who's going to come up and talk about Blip Energy. I also just want to make sure that I highlight each of these startups is partnered with a Minnesota organization to bring that technology here and really pilot, show the use case, the demonstration that's needed to get to these stages of commercialization. So in Spencer's case, working with the University of St. Thomas Center for Microgrid Research, Carba has been working with the City of St. Paul, and Sophia has been working with Minnesota Power. So again, another shout out for Duluth, although her pilot is in Long Prairie, so really another part of our region. So those partnerships are absolutely key. If you want to learn more about the Innovators Network, talk to me, but you're going to be wanting to talk to Sophia more after you hear all about her great tech. So come on up.
Awesome. Thank you so much. I do want to open by just saying, I told
I told Nina this to her face last night, but I think Grid Catalyst is a really, really special program. We've been building Blip for about 4 years. We've gone through a lot of cohorted programs, and I think that there's a really important special gap that Grid Catalyst is filling, sitting between startups and partners. As an early stage startup looking to partner with a large corporate, that's a really tough relationship to navigate. And so having the Grid Catalyst almost arbitrating that relationship and saying, no, this is an appropriate timeline. This is what you can expect. This is what kind of insurance you should be getting in order to do this thing. I think that that's a resource that I just want to shout it out because it's super, super important. It's not something that I've seen in a lot of the other programs that we've gone through, and it's incredibly valuable for startups at our stage. So thank you, because that's a huge, huge deal. Now I will talk a little bit about what we're actually building. So Blip Energy, we're an energy management platform. Also, thanks to Spencer for teeing up some of the problems with demand on the grid, which is going to make my presentation a little bit easier and more streamlined. But basically, we're building a platform to help with peak demand, specifically around the built environment, basically helping take the most advantage of, yeah, great, thank you so much. Okay. The grid can't keep up with our needs. This is a huge problem. It means the cost of energy is going up. The power is going out more frequently. Those things are bad. The reason this is happening is because at every moment the grid needs to manage how much is being generated with how much is being consumed. That is a really tricky balancing act. When it falls out of balance, the grid can melt down. It's part of why the storm in Texas a couple winters ago was so bad, because the grid melted down and it took time to get it back up. Luckily for all of us, decreasing energy demand, even temporarily, like, for example, intelligently charging your car, is just as valuable in this balancing act, and it's a lot more flexible and a lot less costly than building or turning on an entire additional power plant. So what we realized at Blip is that there's a ton of energy capacity that could be used to help with that balancing act. It just needed a different type of solution. So there's solar panels and batteries. That works really well if you're in a single family home where it makes sense to install that. But there's a lot of there's multi-unit buildings like we heard about as well. So what we realized is that they needed a different type of solution. So what we built is something totally behind the meter that doesn't require any permitting. It's a drop-in solution that sets up in about 2 minutes. And we're actually starting with window air conditioners as a load to be able to shift. So what we've designed is this smart battery with a software control platform. You plug your air conditioner directly into the battery. You plug the battery into the wall. You give us some information about your utility when you set up your account, connect it to Wi-Fi. It sets up in about 2 minutes. So now you don't need to have a new air conditioner. You don't need a smart air conditioner because it's plugged into this battery, which is intelligently charging overnight, and then switching that AC over to run off the battery in the afternoon when the grid is stressed and when the cost of energy goes up. So we're starting with window air conditioners, wall air conditioners, those wall units in hotels. Those are a really great market for us to tackle first, but there are other applications with retail refrigeration, those langers that sit open in a convenience store, other plug loads that are a really heavy energy load that could be used to help shift demand. So our end users get all their electric bill savings. They also have backup power if the power goes out. So it's a 2.5 kilowatt hour battery that'll run a fridge for 1 to 2 days. It'll run a sleep apnea machine for about a week. Those are some of the priorities that we hear. It'll charge a laptop 40 times. So having the bill savings, the agency, but also the backup power. We work with demand aggregators, so that allows us to access the market pretty quickly. Basically, they're building a virtual power plant on the demand side. So they're building a portfolio of things that can shift demand, like intelligent EV charging, like smart thermostats. So what this would look like in, for example, New York, where we work with Voltus and Leap, we are paid out by Voltus. They take a commission, and then we actually share a portion of our revenue back to the battery owner. So they're getting paid for participating in these programs as well. And I think smart thermostats did a great job of validating this market, but 30% of households are not set up for a thermostat, and 40% of commercial buildings are not. And one of the things we realized is there's a lot of human factors that go into this as well, right? There's all sorts of buildings that could have solar panels on their roof but don't. There's all sorts of buildings that are well suited for a heat pump retrofit, but they haven't yet. And so we want to make sure that there's an easy drop-in solution because we need these solutions yesterday. So we're going after the market of older buildings that are using those window and wall units and giving them a real solution to save money and help stabilize the grid. We are actually starting by selling to the owners of these buildings, these property owners. It's a really great way for us to have a geographic strategic focus. But long term, that's a great way for us to get a commercial foothold. Long term, we're really planning on working with utilities to help distribute this. They have access to customer education that's really helpful for us. So partnering with them when they're doing customer education about these time of use rates or these variable rates. There's been some pushback on that when people say, okay, well, what am I supposed to do? Just turn everything off? So we can offer a solution where you take advantage of the rates without asking you to turn off your air conditioner. We are a lean team. We are a 2.5 person team right now. My background is in hardware and product. I was a mechanical engineer on Roomba, robotic vacuum cleaners, and I worked as a product manager at Tesla. So I saw a lot of great technology on the residential energy side of Tesla. That again works for a smaller fraction of the population. So I was driven to build something that's a lot more accessible. My co-founder's background is in utility and policy work. So he worked at utilities across North America. He worked on Capitol Hill for General Electric. So he's got all of the context on how we make the most value of this complex energy system. And my job is to build something that people actually want that earns a place in their home or business. We are so excited to run our first pilot this summer. Before that, we wanted to make sure with this new sort of drop-in distributed energy resource platform that we had support across the ecosystem. So we have a grant from the Department of Energy. We've gotten strategic investment from Southern Company, which is one of the bigger utility conglomerates. We validated with Argonne and UL. We know we're certifying as a portable power station. And then we launched our first pilot, and we're working on a couple more with Brooklyn Navy Yard and LA Climate Incubator. The, I think, interesting thing here is that there's a lot of funding. I mentioned that it's a lot cheaper to switch demand than to turn on a new power station. I think that's reflected in the economics. That's why we can have a low-cost battery. We're planning to charge about $800 for this 2.5 kilowatt-hour battery. And then on top of that, share back revenue with the people that are owning the assets. Right now, our focus over the next 12 to 18 months is more demonstration and pilot projects in service of a commercial launch in 2025. So we're raising a $2 million round. We have almost half of it committed. If you are interested, please chat with me. We're also looking for potential pilots this winter with space heaters, which are also the electric resistant space heaters, which are also a huge source of energy congestion. So if you've got connections or interest in partnering on a space heater pilot for the winter, please come and chat with me. And thank you for your attention. I am super excited to be in this room with so many smart people focused on this energy transition. And I will open for questions.
Before we pivot to the group, I stepped up for a moment, did you talk about your Long Prairie pilot?
I did not talk about my Long Prairie pilot. I will do a quick overview on that. So we are working with Minnesota Power in Long Prairie. So we placed 9 batteries in a residential building that they've worked with on energy efficiency programs before. So we set up those batteries to run ACs and do daily load shifting. So we were able to gather a ton of data. One of the things that came out of it that you always find things that you don't expect, right, when you run pilots. So one of the things that I didn't expect is how much difference there would be in how people use window air conditioners. I think we know with a thermostat, it's like, all right, there's kind of a range, like you're setting it between like 68 and 74, that's not crazy. With window ACs, there's a big difference. And so we're actually, from that pilot, now added to the roadmap to develop more profiles. Because you have someone who only turns it on if it's over 85 degrees, and you have somebody else who runs it full blast all the time. And so the more accurately we can predict when you'll be running it. We can look at a forecast and know how many of our batteries are actually going to be engaged. So that's one of many, many learnings from the pilot, but I think just an interesting one that I wasn't expecting. I expected to learn about the software and the hardware and how things are working and connecting, but that human factors one was really interesting. So we set those up in July, and I'm going out there to pick them up tomorrow, Thursday. Yeah.
Yeah, on the slide with the revenue breakdown, you had hardware and software. Could you just talk a little bit about how you expect that to grow and change over time, given that I think it started out with hardware sales being higher and eventually software sales taking over that 3 to 5 year out?
Yeah, absolutely. So the question was around the revenue model and the contribution of basically hardware and software. So initially, hardware costs are a little bit higher as we achieve scale. So there's a couple of different paths for cost down. The main one is that we are basically a year after the battery is deployed is when we start booking that recurring revenue, because we need a little bit of time to vet how much capacity, what profile, how often they're running their air conditioner. So there's also a 1 year lag from when we put the hardware out to when we start booking recurring revenue on it. So those are the two reasons why software sort of overtakes, or services overtake hardware in the contribution there. A couple other things is that as we have a larger fleet of units, we can demand a higher payment for demand response programs. So there's some cutoffs when you have 50,000 kilowatt hours, when you have 500,000 kilowatt hours. So we are bidding these batteries in as a fleet, and as that fleet grows, we basically make a higher per kilowatt hour rate. The last thing I will say, back to the predictives, is that the more accurately we can predict how much capacity we'll be able to use at any given time, the more money we can make per unit, because we don't have to leave such a buffer. So right now it's sort of like, okay, we can assume that maybe 50% of the units in the field will be able to be engaged if there's a demand response event. But if we can be more accurately predictive, maybe we shrink that buffer to 20%, and then we're able to bid in a higher percentage of our field capacity.
Can I ask a follow-up question?
Yeah, for sure.
How much when you're talking with utility companies, how much does like behavioral change in the consumer come up trying to solve the problem of grid consumption? Because a lot of times I think like there's all these great solutions that are out there, but often what is required is a behavioral change in the user of that technology in order to actually see that improvement over the long haul.
Yeah, 100%. The question was around when talking to utilities, how much does behavioral change of the actual user come up? It comes up a lot. And I think that's actually one of the strengths of our solution, is that set it and forget it. We're not asking you to change when you're using your air conditioner. We're changing when that power is drawing on the back end. I think that is also one of the reasons that they're excited with partnering us around time of use rates, because they get a lot of pushback from people who don't want to change their behaviors. So it's the top of the conversation typically, and I think it's one of the strengths of how we've built out this product. Yeah, for sure.
Other questions?
Yeah.
Sophia, how are you considering product life cycle in your design of, say, your batteries?
Yeah. So the question was around product life cycle. Are you thinking, follow-up question to the question, are you thinking like repairability or life of the product, all of the above? Sure. Yeah. So the expected product life is about 10 years. I am a big right to repair girly, so we are designing it to be easily repairable. The way we've designed it now, it's very modularized. So if there's an issue with the inverter, we can just swap out the inverter. If there's an issue with the charging circuit, we can swap out the charging circuit. And when we hit that 10-year mark, which is about 80% capacity life on the battery, we can swap in a new battery pack if all of the other electronics are looking good. I think those are the sort of top priorities. And then also thinking about, obviously, battery circularity, what happens to those packs, can we actually refurbish them and add higher quality cells and use them for something else? But I think those are the high level tidbits. Yes, thanks. Yeah.
So on your test study, are you using that basis on 110 or on 240 for those window air conditioners? Because there's two variations to that.
Yep, so this is a 110. So our first product is focused on 110. we'll have a second product that handles 240. But to start, just 110. Thanks.
Time for one more question?
So how long does the battery last?
Sure.
25 kilometers per hour? How many hours can you get out at that value?
Yeah. So running a typical window air conditioner, there's obviously a lot of variability. We're looking at 3 to 6 hours. That doesn't always cover the entire load shift window. So once the battery's drained, it just pops back onto grid power, but you're still getting the benefit of that shift. When we're looking at demand response windows as well, sometimes 3 to 6 hours doesn't cover the entirety of a demand shift window. So there we're actually looking at the fleet as a whole and staggering them. So we have a certain amount of capacity that we know we can hit for the entire load shift or demand response window. So we're able to sort of be flexible there and make sure that we have coverage for the entire window. But yeah, it runs a typical air conditioner for 3 to 6 hours.
Don't be shy, y'all. This is why we're here.
So if you're staggering which ones are being used at different times, but do end consumers still get like a evenly distributed benefit financially?
Yeah. Yes. Short answer, yes. The question was if you're staggering when they're on, is the financial benefit evenly distributed? And the short answer is yes.
So I've told some of you this. I'm an extrovert, so awkward silences are the bane of my existence. But I'm like, oh, people have to process all this smart information from Sophia. So sometimes we just have to pause and sit in it for a minute, right? Other questions? Yes,
Yeah.
please, Lori.
I happen to just have run all new circuits to my whole house.
Okay.
I wish I had talked to you a year ago. Could one unit power multiple conditions? It's a big house. Window units all over the place because we're in this transition phase of heating and cooling. Could one unit power 4 window air conditioners, 6 window air conditioners? What would that look like?
Yeah, I think short answer for this product is no. So you would want to have one blip per air conditioner, basically. That benefit scales, obviously. Every AC that you're load shifting is that much more money that you're saving. Partly because of the previous question of this runs a window air conditioner, 2.5 kilowatt hours, runs a window air conditioner for 3 to 6 hours. So if you put 4 window ACs on this, number one, the power draw is out of control. There you go. Yeah, exactly. There are, I think the other factor we were considering with design was having a feasibly portable product. So 2.5 kilowatt hours is about a 60, 70 pound battery. There are wheels on the bottom. You can like roll it around the house. But we wanted to make sure that we could have built a 4 kilowatt hour battery, but that's not portable for anybody.
I guess where my brain went is
Yeah. They're sort of, so the other, I would say, difference between what we're building and I think what you're thinking is like you're thinking about something that's tied into the circuits and is powering the home. So that's where you need an electrician. If you're feeding back, you're going to need utility interconnection, whereas this is just drop in and it's only powering what is directly plugged into it. So because we're not feeding any power back into the circuit is how we can have such an easy drop-in product. There are some batteries that we can talk about that might be good for what you're thinking about.
one last round of applause for Sophia.
Thanks, y'all.
Thanks, Sophia. Also, just a little, we're here to support clean tech collaboration from Minnesota, but Sophia's from Chicago, so we're gonna keep trying to lure her further west. I don't know if she's up for it, but we're gonna keep trying. Been a fantastic morning with everybody. A few announcements as we move into lunch. First of all, I'm gonna be a broken record about this. There are seats up front. I'm feeling like the guilty host. Some people just like to stand, and that's super cool, but just making sure you all know there's enough seats for everybody. For lunch, the food will be back by the blueprint wall to that side. Please enter the line to the back side of the room by the startup poster and come this way. We're missing one food item in the lunch, so it gives you a reason to get back up and come back for the momos later. You can take your food outside. We ordered this beautiful day to, again, tell people coming to Minnesota how beautiful it is here. So you can enjoy your lunch outside, or you're welcome to go out into the food hall. And if again, you want to try something from any of the other vendors, I'm sure they'd love it. So we will break for lunch until 1 o'clock. At 1 o'clock, you're going to get the second round of the 2024 startup, so you're not going to want to miss that.